This video is the start of Chapter 10. Chapter 10 is our circles unit. It's also one of our longest units of the year. Excuse me. My advice to you is to be studying a little bit every day. What makes circles difficult is not the content itself. What we're going to do is mostly pretty easy stuff we've done before. The problem is there's so much information that if you don't review some of the older stuff, by the time we get to the end, you're not going to remember what we did way back at the beginning of the chapter. So make sure you're studying a little bit each night as you go through Chapter 10, more so than any other chapter. So here at the very beginning, a circle is a set of all points equidistant from a given point called the center of the circle. So essentially, if I give you this point, all of these points are going to be equidistant, the same distance away from that center. If one point is 8 inches away, they're all going to be 8 inches away. No, we never get closer or further away from the center. We name a circle by the center point. So this circle right here would be circle X. Okay, hopefully we've seen these phrases before. A radius is a segment that connects the center of the circle to the edge. We connect the center of the circle to the edge. So for example, XV is a radius. XU is a radius. XT and XZ. Those are all a radius. Now, one thing to keep in mind about a radius is that all radii being more than one radius, all radii are equal. They're all equal to each other. A chord is a segment with both endpoints on the circle. Both endpoints on the circle. For example, RS is a chord. ZT is a chord. Is UX a chord? No, because X is not on the edge of the circle, so that can't be a chord. It has to be edge to edge. And a diameter, this is a chord that passes through the center of the circle. So, for example, ZT, that's a chord, and it passes through the center. Now, interesting thing about the diameter is the longest chord of any circle. So it doesn't matter how many chords I draw. I can draw an infinite number of chords in the circle where I go endpoint to endpoint. The diameter will always be the longest one. So let's practice some of these terms. Name this circle. This will be circle R. Name radii of the circle. So where are my radii? I see RA, RX, RB, and RY. Name 3 chords. Actually, see 4 of them, so let's name all 4 of them. There's AX because the endpoints are on the circle. There's YB. And then there's AB. That's a chord. The endpoints are on the circle. And then there's XY. Again, both endpoints are on the circle. Name the diameters. So the diameters are chords, but they also have to hit the center of the circle. So that would be AB and XY. So this next section says AB is 18 millimeters. Find AR. So this isn't something we've covered yet, but hopefully you recognize that a radius here, this radius of AR, is half of the chord. A radius will always equal half of the diameter, which means AR has to equal 9 millimeters. If RY is 10 millimeters, find AR and AB. Well, AR is another radius. And in a circle, if I set, what's the very first thing we said? The distance from center to edge is the same all the way around the circle. So RA is another center to edge radius, which means they have to be equal. And then AB is now a diameter, which is double the radius. Then the next question, is AB congruent to XY? And the answer is yes, because in a circle, all diameters are equal. So maybe we should go back to the definition of diameter. A diameter could also be thought of as two radii. Again, radii is more than one radius. In a straight line. So like, going back to this example, ZX is in a straight line with radius XT. Those two radii are in a straight line. So that's what makes up a diameter. Circle properties. These should be pretty instinctual. If two circles have the same size radius, then the circles themselves are the same size. Then that would make the circles congruent. All circles are similar. This last one, this is a vocabulary term, concentric circles. What that means is two circles with the same center point. This would not be concentric circles. That is not concentric, because even though one is totally inside the other, they don't share a center point. If they don't share a center point, they're not concentric. But if they do share a center point, that makes them concentric. So here I have circle A with radius AB, and I have circle A. They're both going to be named circle A by the center point with radius AC. We see in the diagram there, circles can either intersect at 2 points if they overlap, 1 point if they just touch each other once, or no points at all, whether it be concentric or not. They may not intersect at all. Circumference. Circumference is the circle version of perimeter. It's how long is it all the way around the circle. Our formula, actually we have two ways of writing the formula. It's either pi times diameter or 2 pi times the radius. Here's essentially what pi is, because I think maybe previous classes may not have explained it well. What pi is, it's the number of times that this segment, the diameter, if I were to take this segment and I were to bend it, that length would go around the circle 3 and a little bit more times. That's where the 3.14 comes from. So it would go around 3 1/10 time if I were to somehow able to take that diameter, bend it, and place it around the edge. So find the radius and circumference of a circle with the diameter of 16 feet. Well, we know the radius is half the diameter, so the radius is half of 16, so the radius is going to be 8. And we know that the circumference is pi times diameter, so the circumference is going to be 16 pi. And we are going to leave our answer in terms of pi. What does that mean? I'm not going to do 16 times 3.14. It means I'm going to leave it as 16 times pi as my final answer. The same way you would leave a final answer of 4x or 3 root 4, or 3 root 5 with a square root at the end or with an x at the end. We're going to leave pi as its own term. Find the diameter and radius of a circle with a circumference of 52 pi. So if I know the circumference is pi times diameter, and the circumference is 52 pi, I could divide the pi away on both sides, because pi is just a number. It'd be like dividing 2 on both sides. So I get that the diameter is 52. And we know that the radius equals half of the diameter. So if the radius is half of 52, that means the radius has to equal, not 29, sorry, 26. Two more vocab words. These are going to be a bigger deal later on in the chapter, but I want to introduce it to you now. Inscribed and circumscribed. So an inscribed figure is a figure inside of the circle. Now, I want you to notice that in this inscribed figure, all 4 corners are exactly on the edge of the circle. The edge of the circle passes through all the corners. What does that mean? It means if I were to give you this figure here, this is not considered inscribed because this corner is not on the edge of the circle. In order for it to be considered inscribed, every single corner has to be on the circle. Now, a circumscribed figure, that is a polygon on the outside, so all straight edges on the outside, but the circle is exactly big enough to hit all of the sides exactly once. So, for example, if I gave you this guy with this circle, this would not be inscribed because it doesn't hit this edge of the circle, this edge of the figure right here. So it has to hit every side of the figure exactly once. That's what circumscribed means. Sometimes we'll see it, these definitions a little bit reversed. So we could say quadrilateral LMNP is inscribed, and circle K, the outside figure, circle K is circumscribed. So you kind of see the 2 ways right here. These 2 ways are the 2 ways I could describe that figure. I could either say the quadrilateral is inscribed in circle K, or that circle K is circumscribed about. When I say about, that means outside the quadrilateral. So let's draw these and then find the circumference. Inscribed right triangle. What does that mean? Does that mean the right triangle is going to be inside the circle or outside the circle? That means the triangle is going to be inside the circle. And it's a right triangle Now, something that I have to tell you for this particular example, it's going to come up later in the chapter. This is a rule we will eventually need to know. It'll be 2 or 3 videos from now. If I have a inscribed right triangle, then the hypotenuse must be the diameter. Anytime I have an inscribed right triangle, the hypotenuse is the diameter. So I'm told that the 2 legs of the triangle are 7 and 3. How do I find the circumference? Well, if circumference is pi times diameter, then I got to find the diameter. How can I get the length of this diameter? Well, a right triangle is still a right triangle. I'm going to use Pythagorean theorem. And let's see, does that simplify? Nope, that doesn't simplify. So square root 58 is my hypotenuse. So now if I have circumference equals pi times a diameter of square root 58. So that's how we handle a problem like that. I find the diameter, plug it into the pi times diameter formula. Okay. The next one, find the circumference. It is a circumscribed square. What does that mean? When it says circumscribed, that means it's the outside figure. So the outside figure is a square, and inside we have a circle. And it says the side length is 10. Well, if this is a square, then hopefully you notice that going straight through here is the diameter, right through the center of the circle and the square. And that if it's 10 on top and bottom, it's going to be 10 in the middle. So if circumference is pi times diameter, and the diameter is 10, then the circumference is 10 pi. So that's it for this first video of Chapter 10. A lot of definitions. We'll have more definitions in the second video.